Hello friends, this is Professor Rahul Bhavne and in the subject of heat transfer, today we are going to see boiling and condensation. So let's start today's video. So at the beginning, we will see one video where we are observe closely how the water is boiled. Now there is one jar which is heated at the bottom surface. You can observe that there is some layers moving upward. But these are not the bubbles. These are the water content moving upward. This is known as the convection. Bubbles start, then some bubbles get collapsed, some bubbles emit from the hot surface and move to the top. Now the bubble quantity or that portion of vapor content forming on heating plate get increased. And now vigorous boiling, so complete mass gets stirred now. So this is called a pool boiling. So what is the pool boiling? So pool boiling is one in which our heating surface is completely submerged under the liquid. So then we can say it is a pool boiling. Just like suppose I am heating a water for making a tea. So that bottom of that pot get heated by your gas burner or by induction, and that bottom plate will transfer heat to the water inside that pot. So that base plate, heated base plate of that pot is a heating surface. So if heating surface is completely covered by a liquid, that means it is under the submerged in a liquid, then that kind of boiling is known as a pool boiling. Okay. So there are various types, various regions in a boiling. So one by one we will see. First we will see the natural convection in a pool boiling. So as the picture shows, even I supply the heat, this base plate of the pot get heated and its temperature become 103, and rest of the water reach to the temperature of 100 degrees centigrade. Okay. So at the beginning it will rise the temperature from room temperature, then it will rise and reach to 100 degrees centigrade. So suppose the instant when complete water reach to 100 degrees centigrade and due to heating your base plate reach to 103 degrees centigrade. Obvious high temperature having this base plate, so heat will transfer from this base plate to liquid. But as you see, there is not a single bubble is there. So vapor bubble is not there. So whatever be the heat supplied to this bottom layer of liquid, its density will decrease and it will move upward due to low density. And 100 degrees centigrade water, obviously as compared to 103 degrees centigrade water, is colder. So this top side colder fluid will replace this bottom fluid. So bottom fluid receive the heat from heated plate, its density get decreased and that portion will travel upward due to low density, and high density fluid will replace the space. So in this way actual water is moving due to the density difference likewise. And this is called the natural convection. Yet there is no bubble formation is there, only the water having a travel due to density difference. So this is called natural convection. And why pool boiling? So because this pot heated bottom plate, it is under submerge of this water. So this is a pool boiling. In the video also we observed that during starting the bubble was not formed, but there is some kind of movement in a water. Okay. Now the second is subcooled pool boiling. Now what is this subcooled pool boiling? When your water is not reached to saturation temperature. Every liquid having its different saturation temperature. We are considering for water. So water normally boils at 100 degrees centigrade. Suppose our water is reached to 90 degrees centigrade and still we are continuing supplying heat. So what happened, this heated plate, there will be a bubble formation, that is vaporize, water get vaporized and bubble will form. But as this is not completely at saturated temperature, so whatever be the bubble forms, when it detach from this heated surface, it will move upward, and during its movement towards upward, as upward water having lesser temperature than saturation, so heated plate supply heat, it get vaporized, vapor bubble form, this vapor bubble will move upward, but during meanwhile cold fluid will absorb that heat from the vapors and vapor get condensed. So vapor pockets or vapor bubble get condensed and convert into again liquid. So that means bubbles detach from the heating surface, but it is not reached to the top layer of the liquid. It is inside the bulk of this water get collapse and dissolve itself in the water. So this is called subcool boiling. Why subcool boiling? Because most of the water is not reached to the saturation temperature. So it is subcool boiling. If it whole bulk mass reach to the saturated temperature, then it is a natural convection boiling. Next, saturated pool boiling. What happened now in saturated pool boiling? If suppose that whole mass of water reach 200 degrees centigrade. In that case, whatever be the bubble form at the heated plate will detach and it will move upward, air pockets, and it is not going to collapse. Why? Because already complete mass of water reached 200 degrees centigrade. So water cannot absorb more heat. So this vapor bubble will travel upward, reach to the top layer of liquid, and from where it is escaped to the surrounding. So heat will carried from this heated plate in the form of vapor, and this vapor bubble will move upward and that heat will escape into the atmosphere. So when such kind of phenomena is happening there, when number of bubbles, vapor bubbles form at the heated plate, and it will detach and move upward and get collapse at the surface of liquid, that means continuously heat is carried by vapor bubbles and passing to the atmosphere. So that is called heat flux. So amount of heat transfer per unit area, that is a heat flux. So heat will continuously carried by vapor bubbles move upward and escape to the surroundings. Second liquid will come, it will get vaporized, carried heat and move upward and escape to the surrounding. So maximum heat flux will be observed when there is a number of bubbles, but that bubbles detach from the heating plate and move upward and reach to the top layer of liquid. Then only maximum heat flux is possible. This is called saturated pool boiling. So remember difference, when it is called subcooled pool boiling, it means complete mass is not reached to saturated temperature. So bubble, whatever be the bubble form, might be possible they detach, but meanwhile they get collapse and heat will absorb by the surrounding cool water. And saturated pool boiling, that bubble will detach and reach to the top level because complete mass of that liquid reach to its saturation temperature. Here it is a case of water. So water, so complete mass is reached to the 100 degrees centigrade. Now the transition or unstable pool boiling. In the video itself we saw that after some time there is a uh, very fast bubble formation and sludge kind of appearance was there. So this kind of formations are there, and this is why, because now the heated plate is reached to that much temperature where it is not simply forming a small vapor bubbles, but it form a complete vapor pockets. So huge amount of vapors are formed at the heating plate. So there are number of pockets are formed vapors, and these complete vapor pockets then detach from the surface and move upward. And whatever be the liquid replacing that surface will again heat it, but its volume is larger, so it will behave like a pockets, not like a bubbles. And if we observe closely, so the heating surface is almost covered by these pockets. Somewhere we found that heating surface is available for direct interaction with liquid. Otherwise, most of the bottom base surface or heating surface are covered by this vapor pockets, and these vapor pockets larger in volume, it is now detached, move upward, so it will give like a sludge. So sludge kind of boiling is there. So here if we observe that, so base surface reach to 170 degrees centigrade. So obviously amount of water come to this surface easily get vaporized at a larger volume, so it form a larger vapor pockets, and there will be a huge number of such kind of pockets cover on this heating plate. And this having some drawback. What is the drawback? Now the actual water come in a contact with this heating plate is reduced. Why? Because already heating surface having these vapor pockets. Now heat will transfer to these vapor pockets. From vapor pockets it will transfer to liquid, and as vapors is a poor conductor, so obviously heat transfer rate is reduced, because heat transfer rate is depend on what? When heat is carried from heated plate and escape to the surrounding. But if there is a vapor pockets formation on the heating plate, so less amount of water can be come in a direct contact with heat plate, so less amount of heat will be escaped. So because of such kind of vapor formation, pockets formation, now heat transfer rate is decreased. That is called transition phase. Now suppose we are keep heating the water continuously. So one stage we observe that the bottom surface is completely covered by one vapor film. Now here, as the picture shows, now bottom heating surface plate reach to 500 degrees centigrade. Now at this temperature, this heating surface is completely covered by one layer of vapor. Now not a single portion of liquid or water come into direct contact of this heating surface. So heat will travel to this plate base, then from this plate base to this vapor layer, and from vapor layer to liquid, and then from this liquid, when this liquid gain heat, then bubble will form. But in this case, direct heat transfer rate is reduced, because of water cannot come in a direct contact of heating surface, but this complete water vapor layers enhance radiation rate of heat transfer. So by radiation there is a tremendous increase in rate of heat transfer. Now whatever be the heat coming to this bottom heating surface, it will goes into this vapor layer, vapor film, and this from vapor film by radiation, most of the heat will transfer. So when such kind of stable film was formed, then it is called as a film pool boiling. In the previous, in this picture, as we see, there are vapor formation is there, but still some portion is uncovered. So when this pocket is move away, then second liquid pocket will be vaporized and it covers some heating surface. So that is called unstable. There is not a film formation on the complete heating surface. So it is unstable or transition. But when complete film is formed, vapor film on the heating surface, in this case, rate of heat transfer by convection is not that much strong, but by radiation it is tremendously high. So again, heat transfer increases when stable film pool boiling is there. Now the most important, this is the many time asked in SPPU exam, draw pool boiling regime. That means sections. So whatever we saw right now before these slides, we have to include all that understanding or concept in this curve. Now imagine this is our first curve, and this portion up to A point, this is known as natural convection boiling. So what happens when we heat up any water? So water will be tap water, suppose, and it is at a room temperature. So when heat is supplied, so water receive heat, and after some time we observe that there is a natural convection. Natural convection, that means liquid portion due to low density move upward and cold portion replace that space. But there is not a formation of any bubbles. There is only the liquid transitions. So that is called natural convection boiling. And this is up to A point. After some time, if we continue to heat, supply the heat, after this A point, this portion is known as up to C, it is called nucleate boiling. So from A to C, it is called nucleate boiling, and in nucleate boiling, it is divided into two portions. First portion is having a smaller length in terms of temperatures, so A to B, and second portion having a larger length in terms of temperature, that is B to C. Now what happened? Up to natural convection boiling, there is simply a low density fluid movement, that is natural convection was there, which is responsible for heat transfer. Now at point A, bubble, whatever be the bubble form at the heating plate, start detaching from the heating surface and move upward. But as complete water is not reached to saturated temperature, so that bubbles start to move upward, but meanwhile it will get collapse because it is subcool kind of boiling. So upper layer of water is not reached to 100 degrees centigrade. So whatever be the bubble form at point A and move towards upward due to density difference, meanwhile its energy, latent heat, get absorbed by the water and that bubble get condensed, it convert into liquid form. So bubble start detaching from the heating surface, but it not reach to top surface of fluid. So that is the first portion of nucleate boiling, from A to B, bubble collapse in the liquid. But up to B point, we observe that now the total mass of that water reached to saturation. Now after B point, whenever bubble detach from the heating surface, it will not collapse anywhere, it will directly reach to upper layer of liquid where it bursts and release its heat to the surrounding. So from B to C, whatever be the bubbles form rise to the free surface of liquid. And when this is continuous, so number of bubbles form at the heating surface, that means heat is absorbed and get converted into vapor, and that vapor bubbles travels to free surface of liquid and release that heat to the environment. So maximum heat transfer rate is obtained at point C because maximum number of bubbles formation, detaching and bursting at the free surface of liquid is possible. So at point C, we observe the maximum heat flux, and that is called as critical heat flux. Now after this, after point C, we observe that now there are not a single bubble formation. There are now pockets of vapor formation is take place. So number of small pockets are formed at the heating surface, so that direct heating plate contact with the liquid get reduced, because that vapor pockets are act like a barrier to transfer heat from heating plate to liquid. So total heat transfer or heat flux get reduced and continuously reduced, because continuously that sludge formation or vapor pockets formation area increases and direct contact of heating plate with liquid area reduces. So continuously we observe there is a reduction in heat flux up to point D. At this D point, it is called as a Lenfrost point, where we observe minimum heat flux. At this D point, if we continue heating, then we observe that after D point, there is not a formation of vapor pockets on heating plate. There is a stable vapor layer form. Now none of a water particle can directly come into the heating surface plate. Whatever be the heat now, it will transfer to that layer of vapor. From layer of vapor, it will transfer to liquid. But if we still continue heating, now that layer of vapor will dominate other kind of heat transfer, and heat transfer by radiation will be playing a major role. So we observe that after stable film formation, we observe that heat flux again increases. That means the rate of heat transfer per unit area increases. Why? Because of mainly radiation replacing the role of transferring heat. So transition boiling or unstable film boiling, where number of pockets are formed which reduce the direct available heating surface area for water. So we observe reduction in heat flux. It reached to the minimum value when complete heating surface covered by a stable vapor film, that is called film boiling. So after that we observe that there is increase in heat transfer rate, heat flux, because radiation playing the major role. So again we observe a rise in heat flux. So this is called as a pool boiling region, and there are four regions. One is the natural convection, in which not a single bubble is formed. There is a convection current formed due to low density liquid and high density liquid. So warmer liquid will move upward, colder liquid will move downward towards heating surface. Second is nuclear boiling, which is divided into two parts. In first part, bubble forms at the heating surface, detach from surface, move upwards, but it will not reach to the free surface of liquid. It is meanwhile get collapse. Why get collapse? Because its latent heat get absorbed by the surrounding water and it get condensed. So it form again into a liquid. Then after some part, after point B, we observe that bubbles start moving from heating plate and reach to the top surface of liquid. That is called second part of nuclear boiling, where bubble rise and lift up to the free surface, and number of bubbles carrying heat and escaping into the surrounding, so we get the maximum heat flux. But after C point, pockets are formed, vapor pockets are formed at the heating surface, so which reduce the availability of heating surface for water, so heat flux reduce. Now at point D, stable film is formed and radiation will play a major role for transferring heat, so again we observe the increase in heat flux. So this is the most important point, pool boiling region. You have to draw this curve and then explain this. No need to draw this temperature range. You can draw only single arrow line. This is temperature and upward this is flux. Now force boiling. Whatever we talk about, that is a pool boiling, when your heating surface is submerged by liquid. Now suppose there is a heating pipe is there or force boiling is there. So liquid is flowing through the heating pipe. So heat is supplied from this outer surface of pipe and liquid is, suppose same water is there which is flowing. Now when water is flowing at this section, so heat will travel from this inner surface to water. So low density water will be at the inner surface of this tube, and yes, low density, and high density, that is colder water, will be at the core or center line of the pipe. So what happened, this low density or warmer liquid during its flow also it travel towards center, and center water will replace and travels towards surface because of density difference. So it is continuously moving along the pipe, as well as there is some convection current. Now after some time we observe that this water portion get heated to such level where this inner surface now start to form a bubbles. Definitely bubble also travel along the direction of flow, but in comparison to center, bubbles also try to come to the center portion of this flow, and center portion water will replace and try to reach to this inner surface where it is a heating surface now. So here we observe that the center portion is a liquid and inner tube surface side forming a bubbles. If it is a glass tube, so we observe that is there is a bubbles formation, so also called as a bubbly flow. If this is continue, so we observe that this liquid core will be nearly vanishes. That means your bubble will travel and reach to the center portion also. So now you observe that your complete mass of water is a formation of bubble and liquid. Secondly, at the surface we observe that now bubble are not having a small size in diameter. It is just like a sludge, bigger vapor pockets. So we observe that there is a liquid, but mostly there is a formation of bubbles. So it is called as a bubbles in liquid. So completely liquid is formed by a sludge of vapors and liquid. So it is called as sludge flow. If this is continue, so every time what happens, this bubble forms and they try to come to the center and liquid try to reach to the surface, hitting surface. If this is continue, after some time we observe that center portion, we observe there is a vapor now. At the beginning there is liquid and at surface there is a bubbles, but now after some time we observe that there is vapor portion at the center, and whatever be the remaining water is there, that is flowing by this inner surface of this tube. So centrally we observe vapor core, and from inner tube side we observe some liquid water, but this water continuously having a bubbles. So here we observe that there is empty portion of water, because this center portion covered by now vapor, that is called annular flow. So flow is there, but flow is in between this pipe surface and this vapor core. So this is called annular flow. So continuously water level get decreases and vapor level get increases. After this we observe that there is a transition flow. Why transition flow? Because now most of the water get vaporized, and whatever be the small amount of water is there, but they instantly form a vapor pocket. So it is a transition flow. If the transition flow overs, so almost all water get vaporized. So after transition flow we observe the mist flow. That means water get vaporized, but still there are some water droplets. At the beginning there are some bubbles. Now at the towards the end we observe almost there is a vapor but some water droplets. So that is called mist flow. And after some time that water droplets also get vaporized. So we observe completely vapor flow. So this is the region of force flow. And here coefficient of heat transfer. So at beginning this right hand side is a high level of coefficient of heat transfer, left hand side is a low. So at the beginning it is towards high side, and when the bubbles start forming, so bubble or vapor are a bad conductor of it, so its convective coefficient decreases. And when most of the liquid get converted into vapor, so again radiation parts will be there, superheating of steam will be there. So again it will reach to higher side. So heat convective coefficient increases, and in a superheated steam obviously it will be higher one. So this is a force boiling. Boiling when your mass of liquid passing forcefully, just like a tube flow. Now the last portion, that is condensation. So condensation having a two types, dropwise condensation and filmwise condensation. So this is a dropwise condensation. If you observe minutely during rainy season, so we observe that on the glass of window, at the beginning we form a very small minute mist, dust kind of water particles are accumulated. That is called nucleation. Then after this nucleation will adhere to nearby water particle and form a small drop, minute drop, that is called the growth. These minute drops will now attach to nearby drop, that is a collision, and now it is come to the water drop, that bigger size water drop, heavy drop. And when that heavy droplets become sufficiently heavy, so due to gravity that heavy droplet will slide down, and due to its sliding, whatever be the small water droplets or nucleation or growth was there in its path, it will wipe out. So we get again clean line. So this is a picture if it is come in your exam. So we have to draw such kind of schematic. So there are very small mist kind of droplets, some bigger size droplets. When any droplets become very heavy, so it will slide down due to gravity, and this will wipe the portion. So your surface again available for condensation. Now in this case, what is the requirement? Whatever be the surrounding air, it having water vapors, so your plate should have lesser than surrounding air temperature. So when your surrounding air will come in a contact of this plate, so its water vapor get condensed, form a droplets, and rate of heat transfer is always higher for dropwise condensation. Okay. Second final portion is a film-wise condensation. Now, what is a film-wise condensation? So this is second picture showing the drop-wise. So on the surface of tube, we observe there is a drops. So in between two drops, whatever be the portion open is available for heat transfer. But in film-wise, this complete pipe section is covered by a one layer of water. And due to heaviness, these form droplets, and after some time it will drip out, but complete surface will be wetted. So what happened? This is a schematic. When any liquid come in a contact of cold fluid, it will form a one layer, and when this layer become heavy, so it will become like this. At the top side, the thickness of your water layer is less, but towards the bottom it having larger. But nowhere its surface is available for heat transfer directly with the surrounding air, because now surrounding air and cold plate, there is a water layer formation. So water layer will be act like a barrier for heat transfer. So as I said, for drop-wise, when it is wipe out, again your surface is clean and available for heat transfer. But in film-wise, always your surface cover with a film. Because of this, heat transfer rate decrease, because this water layer now act like a barrier for heat transfer. But in drop-wise condensation, after some time we observe complete glass will cover by a layer. So drop-wise after some time get converted into film-wise condensation. Remember this. And drop-wise and film-wise, in comparison to these two, drop-wise condensation use or having a capability to have a larger heat transfer rate, because each time it make free your surface for heat transfer. But film wise, it is already covered by your surface. So when drop wise is possible, so we observe that if there is a oily surface is there, so layer is not formed, but a drop can be formed. And this kind of drop wise condensation or accumulation is a practical application is our windshield of a car. If it is form a complete layer, then visibility get disturbed. So never your windshield having a film wise condensation, it is having always a drop wise condensation. So it will wipe out heavy droplets and your surface will be free again. So hopefully this is understood what is drop wise and film wise condensation, as well as pool boiling and force boiling. So thank you.